Friends, welcome to my channel. Today we have discussed the first chapter of class 9 CBSE board in mathematics. Okay, the first chapter is introduction to number system. So we already discussed the types of number system like natural numbers, whole numbers, then integers, and then integers and rational numbers. So today we discuss a new type of number system which is called irrational numbers. Okay, so here we have the definition of irrational numbers. Irrational numbers are the numbers which cannot be written in the form of p by q, where q is not equal to 0. This type of numbers are called irrational numbers. इसका मतलब जिस भी नंबर को हम p by q के फॉर्म में नहीं लिख सकते कि जहाँ पे q वो 0 के इक्वल नहीं है, इस फॉर्म में जिस भी नंबर को हम नहीं लिख सकते वैसे सारे नंबर्स को हम इरेशनल नंबर्स बोलेंगे. तो हम यहाँ पे एग्जांपल्स देख सकते हैं. √2 is an irrational number. We cannot write it down in the form of p by q. √3 is also an irrational number. We also cannot write it down as p by q form. Same as √15 and same pi. So I can show you how. So here we have, when we find under 2 we have this value, when we find under 3 we have this value, when we find under 15 we have this value, same as pi. So if we observe the number carefully, then we can find out that this √2 this number decimal expansion of this number is a number which is non-terminating and non-repeating. So we also have another definition of irrational numbers as the numbers which are non-terminating and non-repeating are called irrational numbers. Okay, and as you see, this number cannot be written in the form of p by q because the number after the decimal point are non-terminating and non-repeating. If it repeats itself, then we can write it down as like this. So we can find out this, and after one method we can also find out the p by q form, but here it is not possible. So this type of numbers are called irrational numbers. Now we take some remarks, as by observing the numbers on the real number line, we get the following remarks. First, rational numbers plus irrational numbers gives real numbers. So we can say that when we combine rational numbers and irrational numbers, we get all the real numbers. That's why the number line is also called as real number line. Okay, now the second remark is, every real number can be represented uniquely on the number line, and every number on the number line can be uniquely represented as a real number, which means किसी भी रियल नंबर को हम यूनिकली नंबर लाइन पे स्पॉट कर सकते हैं और किसी भी नंबर लाइन के यूनिक पॉइंट को हम यूनिक रियल नंबर में स्पॉट कर सकते हैं. ठीक है. सो नाउ वी हैव अ क्वेश्चन इन माइंड दैट वी saw in remark that every irrational number can be represented on number line, but the question is that how to locate irrational numbers on the number line. So here I give you an example how to locate the irrational numbers on number line. We already shown that root 2 and root 3 are two very famous irrational numbers. So in first example I will show you how to represent root 2 on the number line, and in the second example I will show you how to represent root 3 on the number line. Okay, so in first example, first we draw a number line. Okay, now we take this 1 centimeter. Now we take another line of 1 centimeter and join this end to this end. Now name this as A, B and C. Okay. Now from Pythagoras theorem we can easily find out this length. Okay. So how? We have from Pythagoras theorem that AC square is equals to AB square plus BC square. Okay. We can also represent it as hypotenuse square is equals to base square plus perpendicular square. Okay, as you wish. Okay, now AC square means hypotenuse means this. So AC square is equals to AB. We have AB 1 centimeter, so we will put 1 here and 1 square, and BC also 1, so plus 1 square. Now 1 square is 1 and 1 square is 1, so 1 plus 1. Okay, now 1 plus 1 is 2, so we get AC square is equals to 2. Now by applying both side under root, we can easily find the value of AC. So under root AC square is equals to AC is equals to under root 2. So this is under root 2. Now we can measure this length and take this length from this point wherever it goes, like we assume that it point is here, so we can represent it this point as root 2. Okay. Now second example. In second example we try to draw a perpendicular line of length 1 centimeter here on this root 2 line, AC line. Okay, and name this point as D. Okay, now we find this line. Okay, AD. So again from Pythagoras theorem, for this triangle, Pythagoras theorem for ACD, we have AD square is equals to AC square plus CD square. Okay, now AD is equals to under root AC square plus CD square. Okay, so we have AC is equals to root 2 square plus CD is equals to 1 centimeter. Okay, so 1 square. Now root 2 square is 2 and 1 square is 1, so 2 plus 1, it is under root 3. So we get SE is equals to under root 3. Now we measure this length and take this length from here to wherever it goes on the number line. So here we get root 3. Same, we can represent all the irrational numbers on the number line. Okay. Now we will show real numbers and then decimal expansion. How to represent real numbers in its decimal form. It's very easy. Let me guess a real number like 29. Okay, 29 is a real number. Okay, so now if we want to write it down in the decimal form, so we can simply divide it as 1 and we get the number 0 point. Okay, like 129, 1 into 29 is 29. So the decimal form of 29 by 9, 29 by 1 is 29. Okay, 29 itself a decimal number. Now let me take another example like 3 by 2. Okay, now how can you find the decimal form of 3 by 2? Simply divide 3 by 2. Okay, the 2 ones are 2. Here we get 1. Now taking point we get 10. Then 2 5s are 10. So we get remainder 0. So 3 by 2 is in decimal expansion written as 1.5. Simply. Okay. Now we observe when we divide p by q the following things. We may fall across two cases. When we divide p by q, then either the remainder is 0 or the remainder can never be 0. Okay. So in first case, if the remainder is 0, then the decimal expansion is terminating, is finite, and repeating. Sorry, not repeating, only terminating. Okay. And in second case, the decimal expansion is non-terminating and repeating. Okay, so we can find a third case also, but not in rational numbers. In irrational numbers, in irrational numbers, the number which are decimal expansion is non-terminating and non-repeating, as we saw earlier. Now we can also represent the first case, the second case with terminating and repeating as let me take an example. If we have a rational number like this 3.5727272 continue. Okay, now we can easily represent it as 3.572. Here we observe 72 is repeating. So we take bar or 72. This mark is known as bar. Okay, so we can represent this number as 3.572 bar. Okay, now let us take an example how we can represent the second example, like the non-terminating and repeating numbers are also rational numbers. This type of rational number, how we can represent this type of rational number as p by q form. Okay, so it is very easy. We cannot know this number fully, so we assume this number as x, that x is equals to 0.3 bar. Okay, which is 0.333 continuous. Okay, now we multiply both sides by 10. Okay, 10x is equals to 3.333 continuous. Okay, now in this method, how many digits are repeating? Here one digit repeating, so we take 10x. If there is 2 digits repeating, then we take 100. If 3 digits, then 1000, and as is. Okay, now this is 3.333. okay, so 10x is equals to, now we can write this number as 3 plus 0.333. okay, but we know that this number is nothing but x. We let it as x, so 3 plus x. Okay, now if this x goes on left hand side, then it will be minus sign, so 10x minus x is 9x is equals to 3, and if this 9 goes on right hand side, it will divide 3, so we get x is equals to 3 by 9, or we can say 1 by 3. Okay, simply we can take another example. Let the number is 1.27 bar. Okay, we take an example in which 2 digits are repeating. Okay, so now so we take x is equals to 1.272727, right? Here we can easily recognize that 2 digits are repeating, so we multiply both sides by 100, so we get 127.2727. okay, now 100x is equals to, now we can write this number as 126 plus 1.2727, but this number 1.2727 is nothing but x, so 100x is equals to 126 plus x. okay, now this x subtracts 100x, so we get 99x is equals to 126, and we get x is equals to 126 by 99, which is in the p by q form. Okay, so that's how we can represent any rational number which is non-terminating and repeating in the p by q form. Okay, that's all for the lecture. Thank you for coming to my channel and watch the video. Please hit the subscribe button and turn the bell icon on, so you can get the notifications of our upcoming videos earlier. Okay.